then as we go to the upper Eocene, when things were starting to cool. So this was what we're seeing, the forams were peaking here with the peak temperatures, at least as indicated by the oxygen isotopes, then coming down into the cooling. We're seeing an increase in coral buildups, and but often in like deltaic environments, but also in purely carbonate environments. Mud mounds, coral mud mounds, oftentimes with a fair amount of clay around them. Coming into the Oligocene, there are some, again, we see better development of mud mounds, but still meeting the cluster reef category, not significant coral reefs, or large buildups. Then by the Chattian, we're actually starting to see large coral buildups, but again, they're still of the cluster to segment reef type, not the true framework type reefs. And here's a couple of nice coral buildups from well, this is from the Asmari Formation in Iran. Then, as we come up through the Eocene, again, the Oligocene, we're going to see more cluster reefs into the Miocene. Actually, there's kind of a mixed signal here, and especially in the Mediterranean, but also to some extent in where Al and I worked on the predecessor of the Great Barrier Reef, and that algae tended to be more dominant, that the coral and algae were dominant over the actual coral buildups, and there were also plenty of larger forams in the buildups. And so, but also with the Miocene, we see the splitting of the Tethyan Reef province into the Mediterranean, Caribbean, and Indo-Pacific with the closure of the Tethyan Seaway, and also with cooling. And so the coral algae seem to have been really dominant in the Miocene. I am somewhat suspicious about this bottleneck. Is it a focus on research, or is that a real bottleneck? But we see this is an example from Turkey, Middle Miocene in Turkey, and these carbonate ramp kinds of deposits dominated by larger forams and coral and algae are essentially in outcrop, very similar to some of the things that we saw in Australia, or in the cores from the ocean drilling program. And these are some of the most dramatic Miocene coral and algal beds I've ever seen, and these are from Majorca, but they're also not unlike some that I've seen from the from actually Eocene limestones in North Florida. Okay, what do I want to say about that? Okay, that's our quick view, and now we're seeing the onset of modern reefs. Again, this was primarily focused in the Mediterranean area, but in the Miocene, in the late Miocene, there's a proliferation of actual modern framework building reefs throughout much of the Mediterranean. I strongly suspect myself that this is partly associated, at least, with the increased salinity associated with the closing of the Tethyan Seaway and the development of the slightly higher salinity in the Mediterranean. while still warm enough to support the reef growth. And I mentioned the diversity earlier. These, and also salinity. I've been at this location, and they're just these very, it's a single species of coral, or possibly two species of coral. They grew upward apparently very rapidly, but there are intervals of cyanobacterial stromatolitic kind of growth in between, which indicates to me that there are salinity, high salinity pulses. So the combination of the higher, slightly elevated salinity promotes carbonate production by corals, but you get over about 38 to 40 parts per thousand, and you'll shut it off and go to stromatolitic formations. So the other thing is that there's this, back to the oceans, there's this huge gradient in the temperature of, or the increase in the gradient between the surface waters and the deep waters in the middle to late Pliocene. And what we see is that, so just to summarize what I've been saying in terms of the larger forams, where's my wire? Oh, I'm hitting the wrong button again. Okay, the larger benthic forams, they had these two major expansion periods, and the coral and algae are associated generally a bit before the larger foram peaks, or coincident with it to a large extent. And whereas during those times there was relatively little coral, the apex time for the larger forams in the Eocene is actually associated with the minimum gradient between the thermocline and the deep sea, essentially the warmest poles, warmest conditions in the deep sea, in the Cenozoic. Okay, the coral buildups, on the other hand, they tend to occur at times when both the you have cooling and low points in the del C13 isotopes. Here they're fairly low here, declining temperatures, combination of lows here, and then of course the extreme lows over here. And the other interesting thing is that, as I said, the Paleocene coral buildups were very much like those of the Cretaceous. Then we see the reorganization in the Paleogene, in the Eocene, and then in the Oligocene. And research by Pichon, Xavier Pichon, has shown these bursts of diversification in the Symbiodinium at these times, and of course the big burst that allowed the upward migration of corals and the dominance of corals within the euphotic zone. And is that related to the strengthening of the thermocline? That's the question that we're addressing. And so, but certainly there was the coevolution of the corals and zooxanthellae in the late Miocene and up to the recent. Okay. Oh, and yeah, mesophotic corals versus euphotic corals. So the question then, why can Cenozoic corals make larger buildups on a cooling Earth? And the nutricline, the nutricline, the chlorophyll, phaeophyton, or fluorescence maximum, all tend to occur here at the top of the thermocline, top of the pycnocline, at low light levels. Now, this is partly a high in pigment, but we can actually see that in acoustic signals of the plankton at the top of the pycnocline. Okay, the accretion of a bioherm actually is kind of self-promoting, because the flow over a bioherm actually, good old Bernoulli, it accelerates the flow. And I use this picture of a coral head with crinoids at the top, sitting up there catching the plankton that's coming over the coral head as the current is flowing over the coral head, is accelerated over the coral head. This whole business about the light. We have the fastest growth at high light levels. We have the lower light levels, the red algal zone. Light declines exponentially, of course, with depth, and it's also very dependent upon the water transparency as to how deep it can flow. And so what we've seen here in the one of the things that Luis Pomar has really been exploring and promoting, we have 2 or 3 papers out on it, and that is the potential role of internal waves and their promotion of these mesophotic buildups, both in the past and of course in the present. And so why do we have one other thing. And the increased development of the pycnocline would increase the development of the internal waves. Okay, so warmer, deeper waters with weaker pycnoclines tend to favor the larger forams, whereas the cooler poles, deep in and cooler deep ocean, stronger pycnocline seems to really be beneficial to the corals. There's a lot of other things going on there, obviously. And so why can corals thrive? We've got cooler, shallow waters, reduced photooxidative stress, stronger latitudinal and temperature gradients, producing stronger thermocline, pycnocline, wind systems, all that stuff that Weisberg and Chambers and so forth are interested in. And the chemistry, higher magnesium-calcium ratios and lower PCO2 promote aragonite production, which is what corals produce. And we have the diversification of Symbiodinium dinoflagellates. Inefficient rubisco is not as sensitive in cooler waters. It works better in warm but not warm waters. And the coevolution of corals with the Symbiodinium, and also the diversification of shallow-dwelling coral and algae that produce the magnificent algal ridges in the high-energy zones of the Pacific. And of course, there's a whole lot more. As I said, it's only a 72-page draft that I'm working on right at the moment. And so here's just some summary, is that slightly cooler sea surface temperatures and enhanced mixing results in less photooxidative stress, which is probably a major factor in moving. I mean, we still have plenty of mesophotic coral buildups today, but we also see the very fast accreting shallow water buildups in the late Neogene to Quaternary. And as I said, this is a group of Luis Pomar and Guillaume Mateo Vicens have are from Mallorca. Basetta and Marcella Morsili are from Italy, and we've been, like I said, this is developing this over the past almost 10 years. So thank you.